Good afternoon, everyone. My name is Nathan Kalosa-Kenyon, owner and founder over here at Canosa Consulting. And today we're going to go over part 4, which should be the final part in our FPDS data pipeline walkthrough series. Reason I say final part is it is the final part of our pipeline until we start building analytics on top of all of this preparatory work in our pipeline. Now, it is not the end of our future pipeline, which will be basically a strengthened and improved version of these 4 steps that have been demonstrated in this walkthrough playlist or series, and then a few additional steps as well that we add in the future. So, this is kind of the end of the road for things that we have built currently outside of synthesis, analytics, and calibration of claims. As it comes to the current version of our pipeline, this is where things kind of hit a wall. So, in any case, we will be talking about our keyword extraction pipeline today. Now, we do keyword extraction in 2 other stages of our pipeline. One being here, which is the first iterative loop of our main text preprocessing pipeline, as well as keyword extraction in our topic alignment pipeline. Now, why do we do it a 3rd time, you might ask? Is it not redundant? Well, one, the reason we do keyword extraction in our main text preprocessing pipeline is to extract boilerplate vocabulary, which gets stored and is very useful to us, but it's for a different reason. Now, the keyword extraction that we do during the topic alignment process is useful to us still and aligns with the same keyword extraction purpose that we do in its own process. So we actually store keywords that we discover during our topic alignment process in the same table where we derive or where we store derived keywords from this extraction process. Now that table would be our keywords table. As you can see, we have about 1.2 million keywords, anything from fisheries base to 3D printer to F-35 to a particular IDIQ to agents apparel. You guys get the point, right? We also create embeddings for each of these keywords, the storing the character length, how many times those keywords have been mentioned. Well, this one is how many keywords are in the actual phrase. And then, of course, we classify those keywords with a small model, asking it, what type of keyword it is, and then, of course, what topic is associated with this keyword. So, that's, 3D printing is associated or was derived from the topic 3D printing and manufacturing, so that makes a lot of sense. In any case, once we have assigned topics and provided embeddings for these keywords, it's a little bit out of order in this process. That's okay. Anyway, that's where the keywords get stored in that table. This extraction process is a larger scale version of this. So the difference between this process here and this process here is not only method and techniques are different. Of course, we have the added c-TF-IDF and acronym rejects candidates, along with merging those candidates so that they can be embedded and then aligned via cosine similarity, similar to what we do in the cosine similarity for embeddings with topics, with different documents from our source material. So same kind of technique. As you can see, we reduce, reuse, and recycle a lot of different methods and techniques across our pipeline. It makes it more audible that way. So once we pre-filter those candidate keywords that come from that extraction piece, we then classify them into these different categories. So we say at a high level, keywords are product, vendors, so products or vendors, methods or services, systems or programs, or other. Or we reject it, which should already happen in here, but this LLM pass also rejects keywords if we need to. So you might say, what happens if they fall into this other category? Well, once they're stored in the V2 keywords table, we do a second pass through classification again to see if they can be classified even more descriptively or specifically. Then after we have that keywords table, that gives us a massive Aho-Corasick dictionary. So this is the third time we use Aho-Corasick throughout our pipeline. As you can see, we use it in the main text preprocessing, in our topic alignment, and in our keyword extraction. Super helpful algorithm. What this does is it scans for linking keywords within prime award material, so within the $100 million source award actions, right? It matches that keyword dictionary against every single contract opportunity description. Does a sub-award pass. Sometimes sub-awards have different descriptions. Most of the time they don't. Missing from this pipeline is we also do a pass through all of our site pages, FOIA documents, FAR clauses, congressional bills, contract vehicles, blah, 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 right? Every single thing in our data store right here, even the news, even the strategy plans, the websites, go through this dictionary pass. Now what that gives us is a keyword link knowledge graph that the first version of our keyword links knowledge graph is, let me pull it up, I think it's about 250 million rows. I could be wrong. Yep, so just roughly 250 million row knowledge graph linking all of these keywords to different agencies, different corpus types. We see what models and topics are associated with that. Of course, we're yet to backfill the entity name, which would be the contractor name that's associated with this, the canonical themes, and of course, we see how many times that keyword matches within a particular document. Most of the time, it's just once if it's a very product or service oriented keyword. If it's a piece of government jargon, that of course is going to count a little bit more often. Now, don't think that just because the match count is 1 on each of these, that that's a bad thing. Most of the time, that means that it's a very specific link in this graph. So, in any case, what we can do from here is link all of these keywords back to very specific topics like we've already done here, different canonical topics across government, different vendors or entities, and different contracting officers. And of course, if you're familiar with knowledge graphs, you know that having a linguistic register knowledge graph for federal procurement is pretty damn useful when it comes to aligning with the agency mission from a BD and capture perspective, and also what exact vocabulary words that you might use when writing a government proposal. Wink, wink, nudge, nudge. That is the type of stuff that you can build as a product on top of our service that we talk about in the first video that we ever posted on YouTube, which is this very simplified version. After you have this linguistic register, you can then build a procurement language ingestion mechanism that gives your proposal writing AI tool the ability to use actual government procurement language that is sourced across 250 million rows and matched and linked, and then you can derive relationships between different keywords, and now you're getting into like mapping neural networks and all that good stuff. So we don't have enough time for that in this video today, But I hope you all enjoyed. That was the kind of the final step of this pipeline series. So also, why are these 4 arrows around this process? Well, we can run this as many times as we want to grow this keyword table. Right now, it's about about 1 million keywords. But if we add more strategy material, news material, congressional hearing transcripts, what have you, that are related to procurement, we add those to the dictionary. So the keywords table is a government dictionary asset that we use to build a keyword link knowledge graph. If you are not familiar with what a knowledge graph is, Neo4j, what is a knowledge graph? It pulls up very quickly. You can read this very simple article. Gives you an idea of what this is. What about ontologies? Well, if you guys want a video about our knowledge graph and how we use our ontology to build the knowledge graphs, we can make a video about that in the future as well, because this data pipeline just prepares FPDS for operations. I want everybody to understand that about this series, is that this data pipeline is just the preparation for building the actual engine for FPDS. This is its assembly line, if you will. So everything in the data pipeline walkthrough is just the assembly line. Once we start getting to ontologies and knowledge graphs, I can drop what our ontology looks like and how we use it and all that good stuff.